In the previous section, we described a few examples of parallel loops executing on FPGA. By the end of this module, you will be able to describe and list shared resources on FPGA. In this section, we'll talk about shared resources. So what is a shared resource? It is any resource that is accessed by multiple objects in an FPGA VI. So here we list a couple examples of shared resources. So digital outputs on most targets, analog inputs, analog outputs, digital inputs, non-reentrant sub-VIs, also memory items, registers, and FIFOs, which we'll talk about later on in this lesson. So these are all resources that can be accessed in parallel loops. So let's talk about shared resources a little bit more. Before a task can begin using a shared resource, though, it must wait until the resource is free. So let's take a look at this graphic right here. So let's look at the top graphic. Let's say we've got a shared resource, which is there in the middle, and we've got task 1 that's running and also task 2 that's running. And both of those tasks need to access that shared resource. So let's say task 1, so let's say loop 1 is running and it's using that shared resource. Well, while task 1 is running and using that shared resource, task 2 is sitting there waiting on that resource to be available. So let's say task 1 finishes. Now after task 1 finishes, task 2 can proceed. So if we look at the bottom now, task 1 is just finished, so now task 2 can now use the shared resource. So in the meantime, while task 2 is using the shared resource, task 1 will have to wait if it's trying to use it again. Using shared resources causes jitter within the application. To maximize the determinism of our VI, we need to try to avoid shared resources when we can. So let's take a look at this slide. Can you identify where the shared resources are in this slide? So notice we've got a loop at the top and a loop at the bottom. So there are two shared resources here. So one of the shared resources is the analog input channel. So notice that both of those loops are accessing analog input channel 0, and the other shared resource is analog output 0. So because both loops are trying to access these resources, they're going to have to wait on each other because only one loop can access that resource at a time. Now you can describe and list shared resources on FPGA. Next, we will share latest data between parallel loops running in the same FPGA VI using local variables and share latest data between multiple FPGA VIs using global variables.